In the last lesson, we talked about graphing lines. We were able to graph lines by choosing some x values, finding their corresponding y values, and then graphing them. We talked about other things like x-intercepts and y-intercepts. We looked at vertical and horizontal lines. Today what we're going to look at is we're going to look at the steepness of the line. And we measure steepness of a line and we use slope, and we call that slope. And so that's today's lesson is going to be on slope, and we see here that the slope of a line, this should say of a line, is the ratio of the rise or the vertical change to the corresponding run. And so a lot of times you'll see this rise over run. So M stands for slope. We're going to use that variable to represent slope, and it stands for rise over run. And I'll show you how you use that here. So we want to find this. Actually, just looking at these different lines, we can see that this first one is the least steep. It wouldn't be a very maybe a very fun slope to ski on or to sled on. This one's steeper, and this one's the steepest. So when we measure our slope, we should be able to see that in the numbers or the answers that we get. So we're going to go rise over run, and what we do is we try to find convenient points to use. When I say convenient points, I mean we want to find where they cross these lattice points. So here we see it crosses a horizontal with a vertical, so there's a convenient point, and then I see another one up here as a convenient point. And so what we can do to find the slope of this line is we start from one and go to the other, and we only go vertical or horizontal. So we want to go do our rise first. So we're going up 1, 2. So our rise is 2. So our slope is going to equal rise over run, which is 1, 2, 3, 4, 5, 6, 7, 8. 2 over 8. That obviously reduces, and we should reduce slope when we can, and we get a slope of 1/4, which makes sense. This isn't very steep, and our slope isn't a very big number. It's 1/4. Let's go to this next one here. We want to find the slope of this line. Well, again, slope, which is m, is going to equal rise over run. We want to find two convenient points. I see one right here, and traveling up here, this one looks like a convenient one. Now, this one is steeper than this one. Just by looking at it, we know it's steeper, so we should see that somewhere in the number here. Now, let's start with the leftmost point, and we want to get to this point. We're going to do rise over run. And so here we have 1, 2, 3, 4, 5. We go down 5. Well, down 5 is a negative, so our rise is actually negative 5 over a run of 1, 2, 3. So our slope is negative 5/3. Now it's negative 5/3 is definitely smaller than 1/4 because this is a negative and a positive, but looking at the absolute value part, we have 5/3 compared to 1/4, and 5/3 is larger. So that number there, 5/3, shows that it's steeper than the 1/4. This negative will tell us something else, and maybe you can think about that and realize that on your own, but we will mention that later. This last one, finding our slope again is rise over run. I actually see several points here. We can use really any combination of them. Let's just pick this here. We're going up 1, so our rise is 1 compared to our run, which is 2. So our slope is 1/2. Just sticking with this one for a minute longer. Let's say we chose this point. I'll change the color here. This one and this one. And let's say we started with this point here. It's the same line, so it should have the same slope. And I'm going to do my rise, which is 1, 2, 3, and I'm going down 3, so that would be negative 3. And then I'm going left 1, 2, 3, 4, 5, 6. So left 6, which is a negative 6. But we notice that does reduce to a positive 1/2. So whichever points we choose and whichever order we go, as long as we do rise over run, we get the correct slope. And slope measures the steepness of a line. Okay, find the slope of the lines through the 2 points. So we have 4, negative 3, and 2, 1. So let's graph 4, negative 3. 1, 2, 3, 4, down 3. There's 4, negative 3, and the point 2, 1 is here. So our slope, Let's start with this one. We're going down 1, 2, 3, 4. Our slope, that's down 4, and right 2, which is a positive 2. Simplifying that, a negative 4 divided by a negative 2 is negative 2. You can write it as negative 2 over 1, but we usually don't leave things in that form, so negative 2. Coming to the next one, we want to find the slope, so we'll graph the points. Negative 2, negative 2, negative 6, and 3, 1. It's a range, so let's count these off. We could count them off, but we know this was at negative 6, so we go up 6 and then up 1 more. So this is a positive 7. And then from here to here, we go 2, 3, we have 5. And we have positive 7, positive 5. So our slope is rise, which is the 7, the vertical change over the horizontal change. And so we've got a couple more examples here. Negative 13, 4. Well, I go to negative 13. Well, that's way off my graph. 1, 2, 3, 4, 5, 6, 7. So negative 13, 4 would be way over, even further over there. So let's just put it 1, 2, 3, 4. Negative 13, 4 is here. And 12, 14. So that would be way up here. So this seems a bit inconvenient at times to actually graph these points, and that's the point of this example, is that graphing is not always the easiest or best way to go. So we want to figure out some other way to do this. So our rise has to do with our change in our vertical change. So we want to find what's the difference or distance from 4 to 14. Well, that's 10. We're going from a positive 4 to a positive 14, so our rise is 10. And then how far is it from negative 13 to 12? Well, from negative 13 to 0 is 13, and then another 12. So negative 13 to 12 is 25. And that reduces, 5 goes into both of those, and you get 2/5. So we had some bigger numbers. It was inconvenient to graph. So we're going to come up with another way. Now this one worked out nicely. It doesn't always work out that nicely because there are some things that have to be true or work to actually just think 4 to 14 is 10 and negative 13 to 12 is 25. So what we do is we're going to actually do this one, which has to do with this, helps us get this formula down here. So x sub 1, y sub 1, we don't really know where that is. So I'm just going to pick some point here. This is x sub 1 and y sub 1. Just any old x sub 1, y sub 1. And then there's another point somewhere that's x sub 2, y sub 2. Well, we want to do rise over run. And so our rise is this distance here. Well, I don't know these values. This is a y sub 1 and a y sub 2. So how do I get from here to here? What's the difference between y sub 2 and y sub 1? Well, that's the idea. It's the difference. So you have to subtract. So you do y sub 2 minus y sub 1. Over here, we could have thought 14 minus 4 gives us the 10. So y sub 2 minus y sub 1 over x sub 2. We want to get from here, our x value, to here, our other x value. So how do we find that distance? Well, we can subtract again. We can do x sub 2 minus x sub 1. And this is our formula for slope. We don't always have to graph it. The previous two examples, these two examples, it was pretty easy because they fit on a nice simple graph and we could count it off. But when we got to this example here, this wasn't as easy to graph and work with. So we actually can use this formula, which you need to memorize. That slope, m, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now it does not matter which points you do first, but whatever you do first for y, you choose its corresponding value to go first for x. So over here, I'm going to come back to this example and show how this works. And so this says y sub 2 minus y sub 1. So I'm going to go ahead and take my second one here. So y sub 2, my second y value, minus my first y value. And since I started with the 14 on top, I need to start with its corresponding x value on the bottom. So 12 minus, so x sub 2 minus x sub 1. Well, x sub 1 was negative 13. And so we have 14 minus 4, which is 10. And 12 minus negative 13, well, minus and negative is like adding. So that's 25, and again, that reduces to 2/5. One last thing I need to show you with this. What happens if someone else wanted to start with the 4 on top? If they said, well, this is my second y value. So they have 4 y sub 2 minus y sub 1 minus 14 over, and since I started with 4 on the top, I need to start with its corresponding number on the bottom, so negative 13 minus 12. 4 minus 14 is negative 10. Negative 13 minus negative 12 is negative 25. A negative divided by a negative is positive, and again, this reduces to 2/5. So either way is fine, but whatever you put first on top, you need to put first on the bottom. And please, please, please remember that the y values go on top. So equation for slope, here it is. Find the slope that passes through the following points. We don't need to graph them anymore. We can just use our formula. So this slope, it's going to be y sub 2. So let's pick this one. This is our y sub 2 minus y sub 1, so minus 3. Over, and since I started with negative 5 on the top, I have to start with 7 on the bottom, so 7 minus negative 1. Really be careful with your negatives. Don't make those silly mistakes of having a negative instead of a positive or whatever. So negative 5 minus 3 on top is negative 8. 7 minus negative 1 is 8, and then negative 8 divided by 8 is 1. So this negative 1 has a slope of negative 1. Same idea here. Let's switch it up. Let's go ahead and start with 3 this time. We always start with the y value on top, but here I'm going to start with the first point. So 3 minus negative 7 over, since I started with 3 on top, I need to have it 0 on the bottom. 0 minus 2 is like a 3 plus 7, so 10 over negative 2, which is negative 5, is our slope. And then for our last one, I really do like to have positives if possible, so I'm going to do the 2 first again. So 2 minus negative 2, and then 9 minus negative 11. So this is like a 2 plus 2, which is 4. 9, this is really plus 11 over 20, and that reduces to 1/5. And so if we have 2 points, we can use this slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Make sure you know it. Just a kind of a quick check here or reminder. So when you're given the graph to find the slope, just go ahead and find rise over run by counting. That's what we did in this first example. We found 2 convenient points and then just counted the rise over the run. If you have 2 points, you can go ahead and use the equation we used for the last several examples. Find the slope, example 4, find the slope of the following lines and make a conjecture. Well, if you remember from the last lesson, y equals negative 1, y equals a constant, is going to be a horizontal line that passes through negative 1 on the y-axis. So that's this line here. So that's a review of graphing. Let's find the slope. So we'll find 2 convenient points. And so slope, this point right here, well, we can count it off. Our rise, well, we're not going up or down at all to get to this point. So our rise is 0, and our run is 1, 2, 3, 4. 0 over 4 is 0. So the slope is 0 for a horizontal line, which does make sense because slope measures steepness, and a horizontal line has absolutely no steepness. So the slope of a horizontal line, so that's part of our conclusion, slope of a horizontal line is 0. And then coming to this one, x equals 3. If we remember from last lesson, x equals 3 is a vertical line going through 3, 1, 2, 3 on the x-axis. So vertical line. And so let's choose two points here. Let's just choose these two. So to get from this bottom one to the top one, we go up 1. So our slope is 1. And we don't go left or right at all. So 1 over 0. Well, we cannot divide by 0. This is called undefined. So we have an undefined slope. And this makes sense because this is really ultimate steepness. You can't get any steeper than this, and you can't measure that steepness. It is called undefined. So the slope, these are ditto marks of a vertical line, is undefined. And so we want to be able to link all those things together with horizontal lines and vertical lines. So horizontal lines are y equals a number and their slope is 0. Vertical lines are x equals a number and their slopes are undefined. We want to look at really the 4 different types of slopes. We just talked about these two. And so a positive slope is a line that moves up from left to right. Up from left to right. So that's a positive slope. We could think rise over run. We have a positive number over a positive number, which is positive. So a positive slope. A negative slope will be something that moves down from left to right. So from left to right, it's kind of like when we read, we look from the left to the right. And so if we found slope here, if we picked this point and this point, we would go rise would be down, a negative, right would be positive. So a negative over positive is negative. A slope of 0 is a horizontal line, which we just mentioned. And then a slope of undefined is a vertical line. And so we should be able to know those. If positive slope goes up left to right, negative down left to right. A slope of 0 is a horizontal line because it has no steepness, and an undefined slope is ultimate steepness. That's a vertical line. And that's slope.